Hello, my name is Lila Rodriguez, and today I'm going to be talking about Lassen National Park and forecasting this upcoming year's monthly visitors. So, this is the raw data that I gathered from the Lassen National Park visitors by month. And this data you can't see, but it goes all the way back from 1997. And you can see here that since November has not ended yet, we do not have that data. So our goal is to estimate how many visitors are going to be coming in the following year and how many total visitors there will be at the end of year 2024. So we made five different forecasts, or no, we made three different forecasts, moving average, 3 and 5, and I will get into that and explain what they mean. And then we also use the exponential smoothing method and the linear regression, which is a equation. So this is my results for the moving average 3 and 5, and these are both forecasting methods. And for the moving average 3 and 5, you take the averages of the previous 3 months totals, and that is your estimate for November's totals and visitors. So here you take the past three months totals and average it, and for moving average 5 you take the past 5 months totals and average it. So as you can see here, the mean absolute percentage error is the thing that we are looking at the most. We want it to be as small as possible, because it being as small as possible means that it is the closest thing to the actual data. So 7.32% mean absolute percentage error. So that is the error, how off our estimate is to the actual data. So as you can see for moving average 5, we are a little more off than moving average 3, which means that if we were to choose one of these for an equation, we'd probably choose the moving average 3 method to make our forecast. But if we look at our exponential smoothing and linear regression, exponential smoothing is gathering all these means and making a specific forecast for it. And you can see here it is a lot lower than both the moving average 3 and the moving average 5, which means that we are closer to actually getting to the actual results. And then for the linear regression here, we are farther away. I think we're not the most far, but we are the second most far away from getting to our actual results. And this is the error. And if we compare all of these graphs together, we can see which one lines up the most with the actual data. So this is moving average 3, and this is moving average 5, and this is moving average 3. And you can tell here by looking at moving average 5 that it is more off than moving average 3. There is more gaps in between, which is representing the data that is off. And here for the linear regression line, you can see it's straight because it is just an equation like y equals mc, something like that. But it's just straight, and as you can see, it is kind of skewing more towards the end. It will eventually come back together, but it has a lot of distance from the actual data. And then if you go all the way down here and look at the exponential smoothing method, we can tell that it has worked the best because the lines are matching up to it very, very well compared to all of the other methods. So that is the one that we chose to make our final forecasting. Yes. So this was our estimated data by using the exponential smoothing method to calculate the visitors by month. So as you can see, it doesn't say, but this would be January, February, March, April, so on and so on. And as you can see here, this is the estimated data, and this is the estimated data, and this is the real data. And we can see how far off we are. Some months we are closer, some months we are off. But as we can see, that it did work the best. So, yeah. We can tell.